So in this video, we're still working on constant rate of change, but this time we're also going to see how we can use a graph to find the constant rate of change and to analyze the points on the graph. So what do the points on the graph mean exactly? So I've got this one started here. The graph represents the distance traveled while driving on a highway. So here's my distance traveled on the y-axis and the time on the x-axis. Find the constant rate of change. So in order to do this, we're going to pick 2 points, and so to find the rate of change, pick any 2 points on the line, such as 0, 0, there's 0, 0, and 160, so there's 160, that's the point there. So what we want to do is, well, what's the change from this point here to this point here? Well, as far as distance goes, I go from 0 to 60, well, that's a change of 60 minus 0. And from this point here to this point along time, it's from 0 to 1. So you can see that's 1 hour. Now, they've set this up for us already. Conveniently, they put the change in miles over the change in hours. And that sort of makes sense because don't we usually say miles per hour? Sure. But let me point out to you that the change in miles was on the y-axis. The change of the time is the change on the x-axis. Setting things up as the y over the x. We're going to see that again pretty soon. So from here to here, 60 minus 0. From here, 1 minus 0. Well, you see it's 60 miles an hour, which is nice. But I want you to notice something here. What if we went from this point to this point? Let's just kind of count it out. So I started at 60 and I went to 120. So if we did these two, hey, this is, if I notice, 120 minus 60, I'm looking at this right here. Well, 120 minus 60, that's also 60. And if I did it between these 2 points, 120 to 180, this right here is also 60. So at each one of these points going this way, it's 60. And if I go from here to here, it's 1. If I go from here to the next point here, that's from 1 to 2, that's also 1. And from here, that's 2. To this point here, that's 3. That's also 1. So you'll notice between these points, I go up 60 and over 1. I go up 60 over 1. I go up 60 over 1. In every single case, I'm going up 60 miles for every 1 hour. So the constant rate of change here, 60 miles per hour. So explain what the points 0, 0, and 160 represent. So remember, here's 0, 0. Well, what's it saying? Well, if I've traveled 0 hours, I've gone a distance of 0. Where 160 means after traveling for 1 hour, I've gone 60 miles. To 120, after 2 hours, I've gone 120 miles. That's analyze it. Let's do one quick example. So use the graph to find the constant rate of change in miles per hour. So they tell us how they want this, miles per hour, which is nice because that's a fairly convenient rate that we're familiar with. I'll pick this point here, 130, and this point here, 390. So 130, 390. You can see we're reading between, it's halfway, 30 is halfway between 20 and 40, 90 is halfway between 80 and 100. So let's set this up. The change in miles is going to be 90 from this point here. It's going to be 90 minus 30. And from here, the change in time, or in hours, is going to be 3 minus 1. So what do I have here now? I've got 60 over 2, which simplifies to 30. And again, I need rates, or I need units with the rates. Again, so it's miles per hour. And notice here, this is a unit rate. So there's a unit rate Y, because it's out of 1 hour, as opposed to this here, which is out of 2 hours. This is also my constant rate of change. But I want us to notice something here. Notice if I go to 1 hour, how far have I gone in 1 hour? Well, I've gone 30 miles. So this right here, I can see the unit rate right there on the graph, where the 1 is, 30 over 1 hours, or 30 miles per hour. Okay, let's do a couple of examples. So find the constant rate of change for each table. I'll probably do 2 problems here. Well, notice now they're not telling me, well, how should I set it up? I have to decide for myself. So I'm going to check out, I've got hours here and dollars here. So what rate of change would make most sense? I've got 2 choices, hours per dollar or dollars per hour. Time spent mowing. It's starting to make sense. How much money do I make per hour? So I'm going to set up this. I'm going to write my units first. So now I need to find the change. Well, how far is it from here to here? Well, that's 20. And from 30 to 50 is 20. And from 50 to 70 is 20. When I look here, my change is 2. So change of 2, change of 2. So these are my change, not the numbers themselves. So my dollar rate of change, I'll write this out. Change in dollars is 20. My change in hours is 2. Well, if I simplify this, I can see that I can divide top and bottom by 2, and I get $10 per hour. Again, so there's a unit rate. It also happens to be this rate of change. So again, there's from a table. But you also have to know how to find the rate of change from the graph. So let's look at this right here. So it says find the constant rate of change for each graph. So I'm going to pick 2 points. And when I look at the line, I want to pick up points that I can read easily. So I can read that easily. And I could read this easily. Let's try those 2 points. So what point do I have here? This is the point 5, 55. And this is the point 270. So this is my x-axis, this is my y-axis, and again, they're not telling me how to set up, but I'm going to use the y over the x. That is almost always a smart thing to do. In this case, so I'm going to have degrees Fahrenheit over hours, sort of like the temperature, how many degrees per hour. That sounds like a rate. So I need to look at the change. So what's the change in degrees F? Well, I'll go from this point here to this point here. So that means I go from 70 to 55. So 70 minus 55. Now I'm going to put some color here just so I can sort of keep track of what I'm doing. Notice it's both my y values. Right? Remember, every ordered pair, it's always x, y. And that now I need is my change in hours. And that I get from here. And here I have to be really careful because I started with this point here to here, and I have to do the same for the bottom. So I'm going to have 2 minus 5. It's going to have a negative number here. So if I simplify this, on the top, 70 minus 55 is 15. 2 minus 5 is negative 3. If that's not clear for a moment, let's just do a number line here. So here's 0, here's 1, here's 2, here's 3. So going the other way, 3, 2, 1, 0, negative 1, negative 2, negative 3. So if I started at 2 and I subtract 5, that means I'm going to have to go this direction. 1, 2, 3, 4, 5. I end up at negative 3. Well, so I'm going to have a negative number here. That's okay. What is 15 divided by 3? Which is 5. So 15 divided by negative 3 is going to be negative 5. And again, without units, we don't have a rate. Here's my units. Degrees F per hour. So again, I've got my constant rate of change. So it's my constant rate of change. And because it's out of 1 hour, this is also a unit rate. So, but before we leave this thing, let's go over here. Look, consider this graph. So it's saying negative. Well, a negative change. What does that suggest? Well, it should suggest that temperature is going down every hour. And if I start here, as I increase in hours, as time goes by, sure enough, temperature is dropping, going from 80 to 75 to 70 as I go out in time. So that should make sense. A negative change in temperature means the temperature is going down over time. One little insight into something about slope. You'll notice that this line here is tilted this way. Anytime you see a line tilted in this orientation compared to this will always be a negative slope. More about slope next time around. Hope this helps.